So about number 5. You're multiplying a pair of monomials together, 4x on the one hand, negative 7x squared on the other hand. What did you get for number 5? Yeah. Negative 28x to the third. Everyone agree with that? Negative 28 because it's 4 times negative 7. Multiply the coefficients. X to the power 3 because why? Adding the exponents. And this first factor here has a hidden exponent of 1. So 1 plus 2. And we're adding exponents because we're multiplying these monomials together. Right? Multiplication of monomials turns into addition of exponents. Okay. So let's look at a couple of these other ones from this side of the page to get us a preview for where we're going next with this whole discussion. What about number 6? First of all, how is number 6 different from number 5 and different from the other problems we talked about today? What's going on here that wasn't going on before? Pull out your higher order compare and contrast. Say again? Okay, so you end up using a different strategy here than we've had to use before. How do we know that we need the distributive property in this example? What's your giveaway? What's your clue? Parentheses are one giveaway, although number 5 had parentheses in it and we didn't distribute anything. So the parentheses by themselves are not enough of a clue. What's going on inside those parentheses? Subtraction. So there's the biggest difference between number 6 and the problems that preceded it. Because y to the third power is legitimately a monomial expression. It only has a single term. But what is y squared minus 1? Y squared minus 1. So what kind of an expression is that? I would say that it's not a monomial. It's a what kind of nomial? Yeah. It has multiple terms, right? The fact that there is a subtraction going on inside here, subtraction or addition, means that we have multiple terms to work with. That makes this second expression a polynomial. In fact, if we wanted to be really specific, this expression having 2 terms makes it a binomial. So what's different about this one is we're multiplying a monomial by a binomial rather than by another monomial. And because of that subtraction that's happening inside the parentheses and the multiplication happening on the outside, the distributive property of multiplication over addition applies. So we'll apply the multiplication of y to the third power to both of the terms inside the parentheses. And the first term is going to be y to the third times y squared. And the second term is going to be y to the third times negative 1. And we'll put a plus here. So those are the 2 terms in my product. What's y to the third times y squared better known as? Y to the fifth. Multiply the coefficients, 1 times 1. Add the exponents, 3 plus 2. That gives you y to the fifth. Great. And then what's y to the third times negative 1 going to turn into? Yeah. Just make that negative 1 into its new coefficient, minus y to the third. So that's the new thing that happens when we move from the world that only contains monomials into a world now that contains polynomials with multiple terms in them. The only thing we have to keep in mind now that we didn't have before is the distributive property of multiplication over addition, these little dolphin-shaped arrows over here. And that's the same distributive property that you also would have carried with you into a question like number 7, where 5x is going to multiply all 3 of the terms in its trinomial cofactor. Just to skip ahead on this one, 5x to the fifth minus 15x to the third plus, what's 5x times x going to be? For this third product? 5x squared. Yeah. Now, the last one I want to talk about, I'm going to skip over the process for number 9 really quickly, although I saw some of you do number 9 correctly. What was your strategy? It's a strategy we'll talk more about on Wednesday. What did you do on a question like number 9?
FOIL.
FOIL. which we will talk more about in our next class. FOIL involves multiplying 4 different products together to get your final answer. The first terms, the outer terms, the inner terms, and the latter terms. So when you multiply all of those out, I'm going to skip the arithmetic that ensues because we're going to talk more about it in our next class. End up with y to the 4th minus 16 once all the dust settles. But we'll talk more about that on Wednesday. And I want to put the focus, I want to shine a spotlight on number 10 real quick before we go. How'd you do number 10? X plus 6 squared.
I rewrote it and I just did x squared plus 6x squared, and you just 6 squared.
Okay.
And then I just did that small bracket for 36 plus x squared.
So here's one school of thought on that, is just bring the exponent in, make it x squared plus 6 squared. Who did it differently? Okay. How'd you do it differently?
I just multiplied twice, so the x plus 6 times x plus 6.
Okay, so after all, squaring something means multiplying it by itself, so we could see it as a multiplication problem instead. And from there, you then FOIL, right? The thing we're going to talk about on Wednesday. And here's the point that I want to make about this problem. And the point is that this first way is not going to do it. So it's not okay just to distribute an exponent inside of a binomial base. It doesn't work. The second way is the way that we're going to want to do it. This is another one of those things that I'm going to consistently, once we talk about it on Wednesday, I'm going to hammer you with it over the head until it shows up on the exam, which it will, and until it shows up in the final exam, which it will. So we will get into that when we come back on